Hi, this is Paolo Zamma from Carel Industries, and with this tutorial I will show you the complete life cycle of a 1Tool project, starting from the creation of a new project from scratch till the upload into the Pico. This is the exercise that I'm going to create. It is a simple thermostat direct. I will read the room temperature from the analog input number 1, that is the first that is available. Let's suppose to use a NTC sensor, and I will compare this temperature with a fixed regulation point, a set point of 20 degrees and a fixed differential of 1 degree, in order to manage a stage like this, on-off stage like this. This stage represents the status of the cooling, and I will use it to drive the digital output, that is the relay number 1. Regarding the user interface, I will use a terminal using the display PGD1, which has 8 rows by 22 columns. I will show 2 fixed text describing what there is beside, and here on the right I will show the value of temperature and the cooling status. Well, let's start and create a new solution. What is a solution? A solution is a collection of project application. This is an example of a big solution. A solution for a shopping center, which has 4 projects, one for a chiller unit, another for the air handling unit, heating system, pumps, boilers, and so on, and a rack controller. A typical application, a typical solution has only one chiller, only one project. In fact, all the exercises that we will create in this tutorial will use only one project. Okay, let's go back here, create a new solution. I will call it course solution. All the files will be saved in the C/course solution folder, and here we can select a different folder. All other properties are optional, so we can continue with the next page, where we can define the projects used in the solution. We can start from scratch, creating a new project, as well as we can add, that is, import existing project from other solutions. Well, new project. This is another short wizard. Like before, we have to define the name of the project, course. Here on the right, we have to select the programming language. 1Tool provides 2 programming languages. The first is a graphical language, the function block diagram, called FBD, and the textual language called structured text. The second one looks like the Pascal. Anyway, in all the exercises of this tutorial, I will use only the FBD language. Like before, the other properties are optional. So, next page. Here we have to select the type of controller, target controller I want to use. Here I have a simulation box with a Pico 1 with 2 MB of flash memory, and that controller is identified by this label. The main differences between controllers is number of input and output, of course, the type of input and output supported. For example, the PT1000 sensor are supported only by some controller and not by others. The solid state relay are supported by some controller, not by others. Another difference is the number of serial port. I'm using a Pico 1, it has only 2 serial ports, the PLAN and the BMS port, while other controller, for example the Pico 5, has 5 serial ports. Okay, so for our exercise, Pico 1 is enough. Here below there is the type of display supported by this application. The project have the PGD1 display. It is the one that we need, so it's okay. On the right there are the languages of the text of the display. I prefer to delete Italian and add English. So EN is just an identifier for the English languages, just to distinguish it from the other languages. Anyway, there is a specific exercise for the language, multi-language translations and so on. So for now is enough. Okay, finish. Here is our first window that we will meet in this training. It is the Solution Explorer. The Solution Explorer gives the view on all the parts of the project. So project contains the list of the projects. I have, as we have just done, it has only one project, the course. Network is the part of the solution where I can define the links in Pico in a local network. Project Touch editor is for the PG Touch, but these are matter of other exercises. So open this node. The first strategy contains the part of the project regarding the control strategy, the management of input, output, regulation, and so on. Mask is the nickname of the screen of the display. So when I will say let's create a new mask, means let's create a new screen page, display page. Resources is for the graphical resources, images. Document is a generic container of documents, user manual, test plan, data sheets, and so on. Dependencies and lib regards the blocks and library of blocks, we will see later. Modbus line is for the Modbus master protocol. Okay, I prefer to start from the strategy. It is possible to start also from the mask, but okay, I personally prefer to start from the strategy. So double click or right click open. This is the strategy editor. Before to start to write the control strategy, I show you something regarding the layout of the editor. You can see that there are a lot of windows. It is possible to customize the layout. Okay, it's nothing special. Most of development tool has a feature like this, but I prefer to show you. So you can resize the windows. You can move the window clicking the title bar, click move. You can see that there are the 4 arrows on the border, 4 sides of the screen in order to move the windows in that position. It is possible also to move on the 4 sides of the current work page, as well as it's possible to place a left, right, or over another window. When you place over, you can see that it takes the same space of the other window. This is a good layout because you can see that there are a lot of windows, but the space on the display is never enough. So you can click to show the other windows, click and move to change the order of these tabs. You can click, move, and release to undock that window. Okay, so I can put it back on the left. It is possible to close with no, before I show you that it's possible to hide with the pin the window in order to make them visible when you move the cursor over the tab. Also, this is a good way to save space on the page. After that, I can show you that you can close the windows. So I will close all the windows. And how to reopen them. There is the menu View, where you can reopen the variable list, the Solution Explorer, and the message list. These three windows are also the most used. They are, you can see that the menu are at the first level of the view menu. Why? Because these windows are available in all the editors. The editor of the strategy, the editor of the mask, the editor of the network, simulator, and so on. After that, each editor has specific windows. So this is the strategy editor. So there is a menu with the link with the menu to open the windows specific of this editor. For example, in the strategy editor, there is the library view. Okay, and also other that for now are not important. So keep in mind this menu. If during your development you don't see a window that you expect to have in the display, just click menu and you will find it somewhere here. Last point, once you have defined your preferred layout, you can save the layout, export the layout into a file. You can give a name. My layout. So if later on you are lost, you don't see windows and so on, you can easily import, or that is load, the existing layout. And here is the previous one. We can also reset the layout of the current editor with this menu, of the layout of all editors with the other. Now we are ready to write the control strategy. I told you that we will use the function block diagram language. It is based on blocks. The blocks are grouped into libraries. You can see here in the library view. There are a new project have two libraries for default. You can add others, but we will see later. The Atoms library and the Macro Blocks library. Atoms is called Atoms because it contains blocks which perform very basic function like basic arithmetics, basic operation for input and output, Boolean logic and or not, box for communication, basic converter, basic timers, and so on. While macro blocks contains more complete or more specific blocks like macro blocks for the alarms, macro blocks with Boolean logic but with more inputs, macro blocks for the protocols, the envelope for the compressors, macro blocks for specific devices like the rotary scroll compressor, okay, and so on. The way to use the blocks is this: just click the block, move, and release. Click, move, release, and so on. All blocks works in a way like this. They receive the input to use the value to use from the input pin that are this one on the left. They perform the operation and they returns the value at the output pin. So this block will receive the two value to add from the input pin. It performs the addition and returns the addition, the sum, on the output. Well, so let's go back to our exercise. So in our exercise, we have to read first of all the analog input. There is a block for reading the analog input, which name is analog input configurable. So click, move, and release. Okay, we'll hide the library. So how works this block? All blocks in the library have the help. So just select it, press F1 or right-click question mark. The help describes how the block works. At the end, there are links to specific pages describing the inputs and the output. This block has two inputs, CH for channel type. So the channel is the number of the input I want to read. That is the number that appears in the label in the terminal block. So since we want to read the analog input number 1, I have to specify the number 1 or pass the value 1 to the pin CH. Since the value is fixed, is a constant, I will create a constant using this button, this object in the toolbar. Here in my PC, that button is more or less in the middle of the screen, but you can have it in another part. Why? Because also the toolbar can be customized. So move left or right. So by the way, I will move this toolbar on the left. I will use it later. So the C button, this is a wizard to create a constant. I specify the value, number 1, and finish. So click to place the constant. You can click again to place more than one. And by the way, I can show you that if you press the control, the cursor changes the shape. So when you click, it increases the number. This works with the constant as well as with the variables, but we will see later. Okay, I will delete the unnecessary. Well, now these two objects are not yet connected. To connect them, you have to click one of the two pins from here or here. So click, move, and release. Once connected, they remains connected, even if you move one of them. After that, the type. I told you that it defines the type of the sensor. I told you that we will use an NTC sensor. Here is the NTC sensor is type 0. So you have to connect another constant 0 to the pin. So press again the C, 0, already the right one, and finish. So click, ask or the right button to stop the sequence, click, move, release, and that's all. The block has one output. The output is, here is the meaning of the output. It depends on the type of the sensor. We're using the NTC. So for NTC, the output represents the output expressed in tenths of degree centigrade. This is important, is tenths, not a degree. And this is a very important detail because this regards the variable, the data type of the variable. In fact, in 1Tool, in the FBD language, we can use only two, there are only two data types, Boolean for variables in the range 0, 1 and integer, they are 16-bit signed integer variable, that is for values in the range minus 32,000 to plus 32,000 and so on. But since most many value used in the application of our market are values expressed in tens. In 1Tool there is a support data type called analog that is an integer, you can see here, integer, but the values are shown with the decimal dot. So instead to see, for example, 215, the system will show 21.5. And this is good for the variables we need, for the values that we need, that is the temperature, because it is expressed in tenths of degrees. There is a very important information, that is, since the only difference is graphical, the dot before the last figure, the analog and the integer are compatible. So you can also see here in the screenshot, if you compare a value 215 with constant 21.5, the result is the same. Because as you can see here, the dot is a graphical, just a graphical sign. So where the key point is this: where in a page you see, in a page in the strategy you see the dot, just hide it, and you will see the value that the system uses. So you write 21.5, but the system will use 215. Okay, let's go back to the strategy. So this block returns the value of temperature expressed in tenths of degrees. Now, since we want to show the value in the mask, it seems when you have to pass values among editors, for example, from the strategy to the mask editor, okay, you have to use variables. So if I want to show the temperature in the mask, I have to save the value into a variable. Also for variables, there is a specific button here in the toolbar, is the blue V, that is on the left of the yellow C. So click it. Okay, there are a lot of properties, but don't scare, because the most important are a few of these. And there are also other tabs with other properties, but the most important are, of course, is the name. I will give this name room temp. Here you can use letters, numbers, and the underscore, that is the low line. And the maximum length is 32 characters. After that, this description is optional, but I prefer to write it room. Here, for the description, is no limit, is just a free text, also multi-language. After that, there is data type. I told you that for this value, the best data type is the analog. So since the value is expressed in tenths of degrees, and since the 1Tool for analog shows the dot before the last figure, I will see in the display, or also here, a value like a real. Okay. After that, field access. Field access means that okay, there are two possibilities. Only output means that the system, once you place the value, you use the value of the variable in the mask. If you use only output, will be possible only to show the value. In other words, it means read-only. For the user is read-only. While the opposite is input-output, so that the value will be shown and also can be edited by the user. Is read-write. Format defines how many characters the system uses to show that value. Since we are using a value of temperature, probably a field like this, sorry, I forgot to change it to only output. A field like, not this, but this one is the best. Plus AA.A reminds you that it is analog. This is suitable for values in the range minus 99.9 up to 9 plus 99.9, and for a room temperature is enough. Okay, other properties not important now. So finish, click to place the variable. As I told you before, you can click to place another one, control to increase the suffix, and so on. Okay, delete. Now we have to connect, click, move, and release. So the first part is done because this block reads the analog input connected to the terminal V1, type 0, that is NTC, and writes the temperature expressed in temps into the variable room temp. After that, we have to compare the room temperature with a fixed set point and hysteresis 20 and 1 degree in order to manage this stage. There are many blocks managing the stages, more or less flexible, more or less complete, and so on. For this exercise, I prefer to use this one, GRDCMP. It's a strange name. It means comparator with gradient, something like this. It works exactly as described by the icon. So it compares the input and with a set point that is that defines the middle value of the stage, and differential, that is the half of the wall width of the stage. That is exactly the two values that we have in our exercise. So the input is the room temperature, so we can connect it to the output of the previous block, as well as to the room temperature variable. They are exactly the same. You can see that the variable has two pins on the right and on the left. They are the same thing. There are no functional difference from the two pins, left or right. So here we prefer to connect to the output of the previous block. After that, set differential. So differential are 20 and 1 degree. They must be expressed in temps like the temperature, because the block simply compare numbers. So place another constant, 20.0, and the other is 1.0. To connect the object, I will use this very convenient feature. Just move it close to the pin. You can see that appear a small red triangle, and here is the connection. Here there is a very typical mistake. That is, okay, here is. These are 3 examples: 20.0, 220. A typical mistake is to use the wrong number. So I repeat once again that there is no difference from this and this, because where in the strategy, in FBD strategy, you see or you use the decimal dot, just hide it with a finger and you will see the value that the system will use. In this case is 200. So this and this are exactly the same. While 20, of course, is something different. And so what is the right constant? Since this block compares values, and since the input is a value expressed in tenths of degrees, these two are correct or equivalent, while the other is wrong, is completely wrong. So I prefer to use to define the constant in this way, 20.0. Well, this block compare the input with the set differential according to this operating graph, and returns a value 0, 1 according to this stage, and it defines the cooling status. Like before, we have to save it in a variable, so I will create again the V. This time I could use another way. I will show you this. Right click the pin and you have to click exactly on the pin when the cursor becomes a aim, a pointer. Right click, connect to a variable or connect to a constant. In this case, we'll use connect to a variable. The advantage of this option is that since the pin is a Boolean pin, the variable wizard already preselects the Boolean. It requires a variable in the RAM memory, and here is RAM memory. The block is the pin is output, and here is output. So all properties are compatible with the pin, and so you can save time. So you don't have to change the values of the properties. The only property probably is the name, cooling, description, cooling status 0 off. So Boolean is okay, only output is correct because I want only to show the value and not to modify the value. Well, last step, now we have to drive the digital output 1 with the value of the cooling variable. Like for the previous step, there is a block specific for this purpose. The name of the block is DOUT, digital output. CH, like the first block, is it defines the number of the output. In this case, we want to drive. Is the number 1. So also here I have to create a constant with this button, or as I just done, right click, connect to constant. Number 1. You see that the advantage of this option is that it automatically draw and place the connection. So you can save 1 second, maybe not 1 second here, 1 second there. Maybe at the end of the project you can save maybe 1 hour, 2 hours. Val obviously defines the status of the relay, and in our exercise is the output of the previous block as well as the value of the cooling variable. Well, that's all for the strategy. So this block reads the annual input 1, that is the terminal B1, type 0, that is NTC. It writes the value of the temperature in the variable room temp, that is compared with the fixed set point differential 21 degree. According to this graph, this defines the status of the cooling that is used to drive the digital output number 1. And this is all for the strategy. Well, next part regards the user interface, the mask. We have to show the 2 text, room temp, cooling status, and beside the value of temperature. So let's open the mask editor. So double click on the page of the mask node, or right click open. Also, this editor has a lot of windows, so probably you will need some time to find your preferred layout. This white Rex represents a mask, so new project comes with a new mask. So click it, and the terminal editor give you a preview of the terminal in what you see is what you get system. The mask is empty. Okay, not exactly empty. There is a B, but we will see later what is a B. But anyway, don't delete it. So we have to place fixed text. So somewhere you have the toolbox. I remind you that if you don't see the toolbox or another window, click here, the name of the editor and the name of the window. So these objects in the mask tab are the objects you can place here on this grid. We will use some of them later on in the other exercises. And then tools are the objects you can place in the mask. So for the text, the fixed text, the object is this one. So drag and drop, room temp. I have to shorten because there is no space for the whole sentence. And okay, another one for cooling status. So you can see that you can move the object where you want, so there isn't any predefined layout. Double click, of course, to edit. After that, on the right, we have to show the value of the variable. For this, we have to use another object that is the field. So field is a part of the display where we can show or modify the value of a variable. Click, drag and drop. In these windows, there are two, is divided in two parts. In the upper one, there is the what, and below how. So what is the variable, what variable we want to show is room temp, here is, and the bottom part is how, so the format, the graphical format way to show. You can see that there is a predefined format that is the one that I have selected when I have created the variable. So normally you don't have to modify. So normally you have to select the variable and then go straight to OK. Usually you can move, that position is good, and repeat for the cooling. Click, move, release, here the variable, cooling, and that's enough. Probably you show that here there are a lot of variables. There aren't only the two variables that I have created. There are other more or less 300 variables. They are called system variables, but I will introduce them you later with another specific exercise. Well, just to finish, I can show beside the value of temperature the unit of measurement. So I can simply place a text. I could write degree centigrade. No space. I repeat, degree centigrade. But this description takes two characters. A good alternative is to use a specific character that I can pick from the chart map, that is this one, with the where there is the circle and the C in the same character. So I can save one character in the display. Here is, and move in its position. And also for the mask, that's all. So we have created the solution and the project. We have defined the control strategy. We just finished to edit the user interface. Next step, compile. Compile means translate the high-level language, blocks or mask like this, into a format that the system can understand. For this, there is a specific menu, compile, but I prefer to use this button, this 4 button from the toolbar. The first one is not related to the compile, but is important, is a save solution because it doesn't save only the current mask or the current page of the current editor. It saves all the parts of the whole project in the solution, everything. After that, I introduce you to the other icon, is the verify solution. Verify, it checks for some mistakes, not all mistakes, but only some of them. So it could be convenient maybe every half an hour, 1 hour, 2 hours to click it just to see and fix some mistakes. An important thing is that that button and also the one on the right executes also the function on the left. So saves, verify, it saves and verify, as well as the compile, that is the function that we need, compile solution. It saves verify and compile. So compile checks for all errors and also creates the binary file that we can later upload into the controller. If there are no errors, the message list shows success. So that's good. Next part, now we have two options. The first is the test the software into a software simulator in the PC, and the other is upload, so test the project into the real physical target controller, that is the Pico in our case. Of course, we take this way first. To start the simulator, you can use the play button, and like before, it saves, verify, compile, and start the simulator. If there are no errors, starts the simulator. So you can make any modification and just click the simulator. This is the first window of the simulator asking for the model of the controller you want to, I wanted to simulate. So the bottom part, in the bottom part, I can select the controller by part number. So if you have the Pico in your hands, just see the back, the label in the back, and then you can select it. Other way, you can simulate a generic model, a generic small or a generic medium model. So I will use small because I just need one input, one output. The Pico 1 small is enough. This property is used to show later, in 1 second, the exact number of input and outputs supported by that specific model. So click OK. This is the simulator. A way to see that this is the simulator is the background of the page. Yellow background reminds you that this is the simulator. Okay, I can open the Solution Explorer, also the simulation of the analog inputs, simulation of the digital outputs, the relay. Well, the display is white, is empty. Why? Because I have to start the simulator with a typical play button, and here is what we will see in 2 minutes, in a couple of minutes, in the real physical display. Temperature is 0, and start to increase the temperature. How? Using this button. So click, start to rotate. So the set point is 20 degrees, 1 degree of differential, so I expect to see the cooling on at 21, 20.9, 21, and here is the cooling 1 that is on, and also the relay on, so it works. Okay, if the temperature increases, nothing happens, of course, and go down, and at 20 minus 1, 19, here is below 19, the cooling switch off, and also the relay switch off. Well, it works perfectly, also because it is so simple that it must work. Before to continue with the next part, I can show you another couple of interesting features of the simulator. The first are the watch windows. You can open also using the button in the toolbar. A watch window is a simple list that you can populate with variables in order to see the instant value. So right click, add room temp, and this is the instant value of room temp, as you can see. Another thing is that you can open the page of the page part of the project. So double click, for example, strategy page, the system opens here, the strategy page here is. What is the advantage to have the strategy page? First of all, notice that in simulation, all project is read-only. So here you can't move, double click to edit, delete, and so on. Everything is read-only. So the advantage is that you can see how the project works. if in the mask you see something that you do not expect, you can see the part of the strategy that manage those values. But is more interesting another feature that is the eye that shows the pin values. That is this. So beside the pin, the system shows the current value. It works also for the variables. So this block is working with in 207 set 200 diff 1. In fact, this 207 comes from this block and so on. So with a simple project like this, this feature is not so strategic, but imagine a real project with 100,000 of blocks. So if you have a problem, it could be in could regard 10,000 blocks, but this feature is almost strategic, is very, very important. Is mandatory, I would say mandatory. Just to finish, if the variable is on the page, you can drag and drop and put it in the watch. So with the eye, you can see the instant value where the value is used. With the watch, you can see the values used somewhere in your application, all in the same place. Well, next part is this way, upload. So now we can upload and test the project directly in a real physical target, the Pico. You can see that there is a link to a slide with all the steps to upload the controller. So first of all, you have to connect the Pico to the PC. So you have to disconnect, if you use the terminal, and connect it to the PC through the converter. Well, here is bigger. So you have to use a USB to RS485 converter. USB this side connected to any USB port, and on the other side RS485 to this terminal of the Pico. Don't confuse this terminal to the one on the left, because it is for a completely different purpose. So normally here there is the terminal, so disconnect the terminal and connect the converter to the PC. Okay, after that we have to compile the project successfully. I have already done it, and click the Pico Manager button. Pico Manager is this one, but you can see that it is disabled. Why? Because to click these buttons, we have to stop the simulation first. The button becomes enabled, and so you can click it. So these 5 buttons are important because they allow you to move to the other editors and to Pico Manager. So if, as we will do later with the next exercise, we have to modify the project, since I repeat, this in simulation everything is read-only. So to change to editing, click this to go back to the strategy editor, this to go back to the mask editor, okay, and other button. We need the Pico Manager, so click this. Okay, this is Pico Manager with its windows. First of all, we have to select the port number. The converter we are using is seen by Windows as a serial converter that is connected to a serial port. As probably you know, PC identifies the serial port with a label like COM1, COM2, COM3, and so on. So the point is, what is the port number related to the converter I'm using? So if you don't know, or if you don't remember what it is, I recommend you to use the wizard. The wizard. That is a welcome. Next, it asks you to, no, wait a moment. Try again, wizard. It asks you to disconnect the converter. I have disconnected. Next, reconnect. Okay, reconnected, and here is the COM3. So the converter I'm using is connected to the COM3. So I have to use COM3, it's already done. After that, I have to, okay, just mention this connection type. Local remote means local is the PC converter Pico. The alternative is remote, that means that there is a modem, GSM or analog modem in the middle. But okay, we will use a local connection, and then the address. The address is a number from 0 to 31. If you know what is the address of the Pico you have in front of you connected to the PC, of course, you can change it to manual and type the value here. This is the best option because the Pico will become online faster. By the way, if you don't remember what is the address, you can use the automatic. So is the Pico manager that will try to get online with all the addresses in the range, in the valid ranges from 0 to 31. But obviously this could take some minute more. Just a quick mention for the commissioning USB, because if you're using a controller with the USB port, like PC05 Compact, PC05, PC05 Plus, you can connect the PC to the Pico directly with the USB cable, the same cable of the printer or the same cable used also by the converter. In that case, it is not necessary to set the address because since it is a point-to-point connection, it is not necessary. Okay, I will use automatic. After that, start the connection. Here at the bottom, you see that the Pico is not yet online because it takes up to 20 seconds. But before, I have to switch on the simulator and wait 20 seconds. Now I cut this wait. So here is the controller online. As soon as the controller becomes online, the device info shows the type or model of the controller. As I told you before, I'm using a Pico 1, and then the version date of boot and BIOS, that is operating system, and the amount of memory of the installed in the controller. Now this list becomes active, so these are the files that you can upload or download into the controller. The typical files that we have to upload are the application file, that is one or more files for the mask, and the file for the strategy. So these two files are the result of the compilation we made a minute before. They are already selected. Later maybe we will see some of other files. That's enough. Click upload. Also this phase takes a while, so I prefer to cut this wait. Okay, finish. Upload successfully completed. Now Pico is restarting, so I can close this and disconnect the Pico. And now I disconnect the simulator. I'm disconnecting the simulator from the PC. I'm connecting the display, and now I'll show you the result. And here is our project running the real physical controller. Temperature is low, the cooling is off, so increase up to 21, and here is the cooling on. Now go down below 19. Here is the cooling is off, so it works obviously also in the real physical controller. Okay, next step is not mandatory, is optional, is the backup. It is a good practice to make a copy of the solution in a safe place. So you could simply copy the solution folder, that is in this case C core solution, copy it somehow using the Resource Explorer or Windows or the tool you prefer. You can zip using your preferred tool, but I prefer to use the built-in feature, that is the backup solution. it simply creates a zip file in this path that you can change. In fact, I recommend you to organize your backups in a way like this. I will create a new folder. Core Solution Backup, this is a good name. And give a name to the file. The default name is good because it is the solution folder and today. But I recommend you to add some other information like the version level of this program, version 10, 11, 20, and whatever else. Since it is an exercise, a good name could be this, Thermostat. Exercise 1, Thermostat. This is a good name. Save. Start. Okay, now the backup is done. After that, we could start with the next exercise. So starting modifying the control strategy and the user interface and so on, as well as we could restart in case of errors at compile time or errors at the debug time. Well, that's all for our first exercise. Thank you for watching this tutorial.